Welcome to the deep dive. Today we're going to be looking at how Singapore is using open source to revolutionize physics education.
Yeah, it's pretty amazing.
Yeah, if you've ever wondered how technology is shaping the future of learning, or maybe you just like to see how other countries approach education, this is going to be a really interesting deep dive for you.
I think so, especially as more and more countries are starting to explore the potential of these open educational resources.
For sure, for sure. Our source material today is a page directly from the Open Educational Resources / Open Source Physics at Singapore website.
Oh,
And it's focused on a specific workshop series for students,
cool.
like think high school and early college level, and they're learning all about dynamics,
Dynamics.
which is just a fancy way of saying how objects move and interact with forces.
Right.
Yeah.
So the workshop itself actually took place back in 2016.
Oh, wow. Okay.
But the principles behind it are even more relevant today than they were then.
Absolutely. So why is this open source physics initiative so special? I mean, the name kind of gives it away, right?
Yeah, I mean, the key here is that all of these educational materials, they're not locked away
Right.
behind paywalls or, expensive software.
Oh, I see.
Imagine a world where teachers and students, no matter where they are,
Yeah.
can access high-quality physics simulations and resources without any financial barriers.
Right.
That's the power of open source.
Talk about leveling the playing field. I mean, that really makes you think about the possibilities for students in underserved communities,
But
for
absolutely.
those who might not have access to the latest textbooks or software.
Exactly. And what's really cool is that you can actually explore the simulation that they developed for this specific workshop.
Wow.
Yourself, the link is right there on the page. It's a http://wheeler.blogspot.sg/2016/02/dynamic-force-for.html.
So we'll definitely link that in the show notes.
Definitely.
So as we're exploring this webpage, I'm noticing a few things that really stand out. For one, there's a link to a whole section dedicated to interactive resources
Oh, yeah.
within the Open Source Physics at Singapore site.
Yeah.
And you can find that at https://iwanttostudy.org/ospsg/index.php/interactive-resources/physics/O2-Newtonian Mechanics/O2-Dynamics.
Wow, that's a mouthful.
I know, right? It's like a digital treasure chest of physics
Well,
simulations.
that sounds like it. And, that really ties into a larger trend that we're seeing in education overall.
Yeah.
A move away from traditional textbooks
Hmm.
and lectures towards more hands-on interactive learning experiences.
I mean, think back to your own school days, right? I'm sure you can remember a few lessons where you were just sitting there, just trying to absorb information passively.
Really? Yeah.
But then there were those moments where you got to actually do something.
Yeah.
Maybe build a model, conduct an experiment, or interact with the simulation.
Right.
And those were the lessons that really stuck with you.
Absolutely. When you're actively engaged in the learning process, you're not just memorizing facts.
Right.
You're developing a deeper understanding of the concepts and how they apply to the real world.
And that's exactly what these interactive simulations allow students to do.
For sure.
They can manipulate variables, test hypotheses, and see the results in real time. It's like having a virtual physics lab at your fingertips.
And, if you think about it, this approach to learning, it's much more aligned with how scientists and engineers actually work in the real world.
Yeah.
It's all about experimentation, problem solving, and collaboration.
Okay. I'm already convinced that interactive learning is the way to go.
Great.
But tell me more about how this specific website is designed to support that. I'm noticing some interesting features here.
Yeah, well, one thing that really stands out to me is their attention to user experience.
User experience.
You know how frustrating it can be to get lost in a website, especially one with a lot of content.
Oh, absolutely. I've definitely been down those digital rabbit holes before.
Right. Well, it seems like the creators of this website were very mindful of that they've incorporated what are called breadcrumbs, which is a great way to help users visualize their path through the site and easily jump back to previous sections.
Oh, that's me.
It's a subtle but important detail that speaks to their commitment to creating a user-friendly learning environment.
It's like leaving a trail of digital breadcrumbs so you never feel lost in the forest of information. I love that analogy.
That's a good one.
And speaking of navigating through information, I'm intrigued by this popular tags section at the bottom of the page. It gives us a glimpse into what topics are trending among the users of open source physics at Singapore.
Oh, cool.
We see tags like transfer of thermal energy, worksheets, mathematics, and more.
That's a great observation. It
Yeah.
makes you wonder what those tags tell us about the needs and interests of the community.
Yeah.
Are these topics particularly challenging for students,
Right.
leading to a higher demand for resources? Or are they areas where teachers are eager to incorporate more interactive learning tools? It's definitely something to ponder.
I'm thinking this could be a goldmine of information for educators and curriculum developers.
For sure.
Imagine being able to see in real time what topics students are struggling with or what areas are sparking the most interest. It could help teachers tailor their lessons and resources to better meet the needs of their students.
That's a brilliant point. It highlights how open educational resources can not only provide access to high-quality material,
Right.
but also create valuable feedback loops between educators, students, and the wider community.
Okay, so we've talked about the benefits of open source, the power of interactive learning, and the importance of user experience.
Right.
But there's one more piece of the puzzle that we need to address, and that's licensing.
Yes.
I see here that the website states that its content is licensed under Creative Commons, specifically the Attribution Share Alike 4.0 Singapore license.
This is a crucial aspect of open educational resources.
Yeah.
Essentially, this license allows anyone to freely use, adapt, and even remix the materials, as long as they give proper credit to the original creators.
I see.
It's all about fostering collaboration and innovation.
So imagine a teacher in, say, South America wanting to use some of these simulations in their classroom.
Yeah.
They wouldn't have to worry about copyright restrictions or paying hefty fees.
Right.
They could adapt the materials to fit their specific curriculum and share their modifications with other educators around the world. It's a beautiful cycle of knowledge sharing and collaboration.
Precisely. And that's the essence of open educational resources, to break down barriers, promote equity, and empower educators to create the best possible learning experiences for their students.
And there's one little caveat here. The webpage mentions separate commercial use terms for the Easy Java Simulations library.
Okay.
And they even provide a contact email fem at .eespumperies for inquiries. So if someone is thinking about using these resources for commercial purposes, they should definitely do their due diligence and reach out to the folks in charge.
Yeah, it's a good reminder that even in the open source world, there are still legal considerations and intellectual property rights to be respected. But overall, this commitment to open licensing is a powerful statement about the values that underpin open source physics at Singapore.
Right.
It's all about sharing knowledge, fostering collaboration, and democratizing access to education.
Yeah. All right, so we've covered quite a bit of ground already, but there's still so much more to explore on this webpage.
Oh yeah, we're just getting started.
It's like we've just scratched the surface of a vast and fascinating universe.
Exactly, and that's what makes this deep dive so exciting.
Right.
We're about to venture into a world of interactive simulations, virtual labs, and innovative teaching methods. Are you ready to continue our journey?
Absolutely. I'm eager to see what other treasures we can uncover. But first, let's take a quick pause to let our listener absorb all this amazing information.
Great idea. We'll be right back to delve even deeper into the world of open source physics at Singapore. Now, before the break, you mentioned there's a lot more to explore on this page. I'm particularly intrigued by this massive list of links that they've provided.
Yeah, it's like they've created this curated library of resources for physics educators.
That's great.
But I have to admit, I'm a little overwhelmed just looking at this long list. Where do we even begin?
Well, instead of getting lost in the sheer volume of links,
Yeah.
maybe we can take a step back and look for some patterns. What kind of themes or categories are you noticing?
Okay, yeah, good point. I'm seeing a lot of links related to TRIASI. What is that all about?
So TRIASI stands for Teachers, Resources, and Ideas for Active and Successful Instruction.
Wow, that's a mouthful.
It's an initiative by Singapore's Ministry of Education to support teachers in incorporating technology and innovative teaching methods.
Oh, that's cool.
So these TRIASI workshops that they're linking to, they provide professional development opportunities for physics teachers, equipping them with the skills and knowledge to effectively use these resources in their classrooms.
That makes a lot of sense. It's like they're not just throwing these resources out there and expecting teachers to figure it all out on their own.
Right.
They're providing ongoing support and training to help them really integrate these tools into their teaching.
Exactly. And when you look at the titles of these workshops, it's clear that they're covering a wide range of topics,
Yeah.
from very specific physics concepts like Faraday law
Right.
to more general tools like Tracker for video analysis.
Oh, speaking of Tracker, that seems like a particularly versatile tool. I can see how it could be used to analyze all sorts of phenomena, everything from, projectile motion to collisions to oscillations.
Absolutely. Imagine students designing their own experiments, filming them with their smartphones, and then using Tracker to analyze the results. It's a fantastic way to make physics concepts come alive and connect them to real-world applications.
That's hands-on learning at its best, and I love how accessible it makes scientific inquiry.
Yeah.
You don't need expensive lab equipment to study physics, just a smartphone and some creativity.
And that ties back to one of the core principles of open source,
Right.
right? Making education more equitable and accessible for everyone.
Right, and it's not just limited to traditional physics experiments.
Right.
I bet Tracker could also be used to analyze videos of sporting events,
Oh, yeah.
amusement park rides, or even just everyday occurrences.
Absolutely. The possibilities are endless. It's like having a portable physics lab in your pocket.
I'm also seeing a lot of links related to mobile apps.
Oh, cool.
That's pretty forward thinking, considering how ubiquitous smartphones and tablets have become in education these days.
It speaks to the adaptability and responsiveness of Singapore's education system. They're not afraid to embrace new technologies and find creative ways to integrate them into the learning process. And think about it from a student's perspective. They're already using their phones and tablets for everything else, so why not use them for learning too?
It just makes sense, and it helps to break down the barriers between formal and informal learning. Physics can happen anywhere, anytime.
Exactly. It's about making learning more relevant and engaging for students.
Okay, so we've got workshops, simulations, mobile apps, video analysis tools. What other categories are you seeing emerging from this list of links?
Well, there are a number of links that point to presentations and resources from international conferences
Oh, wow.
on learning and pedagogy.
Okay.
So this suggests that open source physics at Singapore isn't just an isolated initiative.
Right.
It's part of a much larger global movement to promote open educational resources and innovative teaching practices.
That's so inspiring. It's like this little web page is a window into a whole world of educators who are passionate about sharing knowledge and transforming the way we learn and teach.
It highlights the importance of collaboration and cross-cultural exchange in education.
Yeah.
We can learn so much from each other by sharing our experiences, our successes, and even our challenges.
Now I have to ask about this link titled, How to Generate JavaScript 3D for Use in Open Source Physics. Are they encouraging teachers to become programmers?
Not necessarily. While some teachers might have the skills and interest to delve into coding, the focus here is more on providing them with the tools and resources to create customized learning experiences, even without extensive programming knowledge. It's about empowering educators to tailor the learning experience to their students' specific needs and interests.
So even without being a coding expert, teachers could potentially modify existing simulations or even create simple ones using these JavaScript tools.
Exactly.
It's all about providing educators with a flexible toolkit to enhance their teaching. And remember, these open source tools are constantly evolving and improving thanks to the contributions of a global community of developers and educators. It's a beautiful example of collaborative innovation.
And speaking of innovation, I'm seeing a link to a Ministry of Education Gold Energy Award 2016 HQ. It's fantastic to see this initiative being recognized and celebrated.
Absolutely. Awards and recognition can play a vital role in motivating educators and encouraging the adoption of innovative teaching practices. They also help to raise awareness of the incredible work being done in the field of open education.
Okay, I'm starting to get a much clearer picture of the scope and impact of open source physics at Singapore. It's not just about providing free resources.
Right.
It's about creating this vibrant and supportive ecosystem for educators to learn, collaborate, and innovate.
And it's about empowering students to become active learners and explorers of the scientific world. Well said. Now, I know we've been focusing on the broader categories of links, but there are a few specific ones that have really caught my eye. Can we dive into those in a little more detail?
Absolutely.
Yeah.
I'm always up for a deeper dive. Which links are you particularly curious about?
Well, there are several related to EJS, which stands for Easy Java/JavaScript Simulations.
Okay.
And there's one specifically titled Exploring Interactive Nets and 3D Visualization with the new EJS Simulation. That sounds particularly intriguing.
That's a great choice.
Uh-huh.
EJS is a really powerful tool for creating interactive simulations that can help students visualize complex concepts, especially in 3 dimensions. It's like taking a virtual tour inside the world of
Or
physics.
like something out of a science fiction movie.
Right.
I can see how this would be incredibly engaging for students and help them develop a much deeper understanding of these abstract concepts. But I'm curious, how user-friendly is EJS? Would teachers need a lot of programming experience to create these simulations?
That's the beauty of EJS. It's designed to be relatively easy to use, even for those with limited programming experience. There are tons of tutorials and resources available online, and the EJS community is incredibly supportive and helpful.
Oh, that's great.
So teachers could definitely create their own 3D simulations to illustrate specific concepts or tailor them to their students' learning styles, even without being coding experts.
That's fantastic. It really empowers educators to become creators of their own learning materials. And speaking of creating learning materials, there's another link that caught my eye. Unlocking Chemistry with EJS. Dive into the interactive world, molecular and symbolic representation, electrolysis simulation by Sheena. Wait, chemistry. I thought we were diving into physics.
But the boundaries between scientific disciplines are often blurred, especially when it comes to educational resources. And this is a great example of how a tool like EDS can be applied across various subjects.
So this link suggests that EJS can be used for chemistry simulations as well. It's like a multi-tool for science education.
Exactly. Its flexibility and ease of use make it a valuable asset for educators in a wide range of fields. And what's really neat is that this particular simulation was created by someone named Sheena,
Oh, wow.
which suggests that educators themselves are actively contributing to the development and sharing of EJS resources. It's a true community effort.
That's what I love about open source. It's all about sharing knowledge and empowering everyone to contribute. And it's not just limited to teachers and developers. Students can also get involved in creating and modifying simulations. Imagine the sense of ownership and accomplishment they would feel.
It's about fostering a culture of creativity, collaboration, and lifelong learning.
Now, there's another EJS link that seems a bit more basic. Mass or weighing scale model JavaScript simulation, applet HTML5. Why would something as simple as a weighing scale need a simulation?
That's where the power of interactive simulations really shines. Even seemingly simple concepts can be explored in depth and from different angles using EJS.
So this simulation might allow students to manipulate variables like the mass of the object or the gravitational field strength to see how it affects the reading on the scale.
Precisely, it's about giving students a virtual playground to experiment and test their understanding of fundamental concepts. It's a far cry from passively absorbing information from a textbook.
I'm realizing that these simulations aren't just about visualizing things, they're about active learning and exploration. Students can ask what-if questions, make predictions, and see the results of their actions in real time. It's a much more engaging and effective way to learn.
And it helps to develop critical thinking skills and problem-solving abilities, which are essential not just for science, but for any field of study.
I'm also noticing some links to virtual versions of lab equipment like vernier calipers and micrometers. Those are fantastic tools for teaching students about precision and accuracy in scientific measurements.
And think about the practical benefits. It's much more cost-effective to provide every student with a virtual micrometer than a physical one.
Oh, for sure.
Especially for schools with limited budgets. Virtual lab equipment can make high-quality learning experiences accessible to a wider range of students.
It's like we're breaking down all the barriers to science education, financial, geographical, and even physical.
It is,
Yeah.
and it's all driven by this shared belief that everyone should have the opportunity to explore the wonders of science.
Okay, this deep dive has been an absolute eye-opener.
It has.
I'm seeing open source physics at Singapore in a whole new light. Now, it's so much more than just a collection of free resources. It's a movement, it's a philosophy, it's a vision for a more equitable and engaging future of education.
Beautifully put. And it's a vision that's gaining traction globally. More and more educators are recognizing the value of open educational resources and the power of collaboration. It's an exciting time to be involved in science education.
I'm feeling incredibly inspired, but before we get too carried away, I want to make sure we're giving our listener time to process all this amazing information.
Good point. Let's take a moment to let all this sink in, and when we come back, we'll explore a few more intriguing links that highlight the community-driven nature of this initiative.
So we were talking about how open source physics at Singapore is like part of this larger global movement.
It really
And I'm
is.
seeing a lot of the links on this page point to resources that emphasize collaboration and community.
Yeah, that's a key aspect of open educational resources in general. It's not just about creating and sharing materials. It's about building a supportive network of educators who can learn from and inspire each other.
And this link titled OER10/15 GWF Understanding Teacher Learning Community as Support for Implementation of Open Source Physics for Conceptual Instruction seems to really highlight that community aspect.
Yeah, it does. Now, while we can't say for sure what GWF stands for, probably refers to some specific grant or funding program
Right.
that supports this initiative. But the main takeaway here is the emphasis on building a teacher learning community.
Right.
It recognizes that implementing new teaching methods and resources, it can be challenging.
Yeah.
And teachers need support and guidance from their peers.
It makes me think of those online forums and communities where people share tips, troubleshoot problems, and celebrate each other's successes. Having that kind of support system, I think, can make a huge difference, especially when you're trying something new and innovative.
Absolutely. Imagine being able to connect with other teachers
Mm.
who are using these open source physics resources in their classrooms.
Yeah.
You could exchange ideas, share best practices,
Right.
and even collaborate on new simulations or activities. It's a powerful way to foster a culture of continuous learning and improvement.
And it's not just about practical support. It's also about building a sense of community and shared purpose among educators.
For sure.
Knowing that you're not alone in this journey, I think, can be incredibly motivating and inspiring.
That sense of community is especially crucial when it comes to promoting open educational resources, which are often seen as a departure from traditional teaching methods. Having a network of like-minded educators can help to build momentum and encourage wider adoption of these innovative approaches.
This really makes me appreciate the human side of open source physics at Singapore. It's not just about the technology, it's about the people who are passionate about making physics education more accessible, engaging, and effective for everyone.
And it's a reminder that anyone can be a part of this movement. You don't have to be a teacher or a developer to contribute. You can share resources, support open initiatives, and advocate for more equitable access to education. Every little bit helps.
Well said. Now, there's one more link that I'm really curious about. SSTRF ETD 21 Gravity Physics by Inquiry. It seems to be pointing to some kind of research project or funding initiative related to gravity physics education.
That's interesting. SSTRF probably stands for something like Singapore Science and Technology Research Fund, and ETD could be Education and Technology Division. But what really catches my eye is the phrase gravity physics by inquiry.
Right. That suggests a move away from traditional lecture-based teaching towards a more hands-on, student-centered approach. What exactly does inquiry-based learning look like in practice?
Imagine a classroom where students aren't just passively absorbing information about gravity.
Right.
Instead, they're asking their own questions, they're designing experiments, collecting data, and drawing their own conclusions. It's about fostering curiosity, critical thinking, and a deep understanding of scientific principles.
So it's less about, here's the formula for gravitational force, now plug in the numbers, and more about, hey, why does that apple always fall down? Let's investigate.
Exactly, and this Gravity Physics by Inquiry project probably provides teachers with a framework, resources, and activities to guide students through this process. It's about shifting the focus from rote memorization to active exploration and discovery.
I can already picture students building their own mini pendulums, dropping objects of different masses to test Galileo's theories, or even designing a mission to Mars. The possibilities are endless.
And that's what's so exciting about inquiry-based learning. It ignites a sense of wonder and empowers students to become active participants in their own learning. It's not just about teaching physics, it's about cultivating lifelong learners who are curious, engaged, and equipped to tackle the challenges of the 21st century.
This deep dive has been an incredible journey. We started with a single web page and ended up exploring this whole universe of innovative teaching methods, open educational resources, and passionate educators who are dedicated to transforming the way we learn and teach.
It's truly inspiring, and it's a testament to the power of collaboration, creativity, and a shared vision for a better future of education.
I have to say I'm feeling pretty energized and hopeful about the future of education after this deep dive.
Me too. It's a reminder that change is possible and that we all have a role to play in shaping that change, whether you're an educator, a student, or just someone who's passionate about learning. There are countless ways to get involved and make a difference.
Well said. So, to our listener, the one who's been with us on this amazing adventure, we encourage you to explore the resources we've discussed today, connect with the open source physics at Singapore community, and never stop questioning, exploring, and sharing your discoveries with the world.
The journey of learning never ends.
And on that note, we've reached the end of our deep dive, but we hope this is just the beginning of your exploration into the exciting world of open education. Until next time, keep learning, keep sharing, and keep the flame of curiosity burning bright.